Greetings, folks. This is Ian from the Electromaker Show. Today we have something a little bit different and very special. Eben Upton, who is the creator of the Raspberry Pi and leads the Raspberry Pi company to this day, took some time out of his day to have a chat with me about the RP2040 microcontroller, the new Pi Pico W, which at the time of filming has just been released, and a lot of things to do with Raspberry Pi, past, present, and future. We actually started recording this interview in his car, and he was concerned about the audio quality, so he then drove home so that we could restart it again with better audio, which is why this interview begins somewhat in medias res as we retread some of the ground that we'd already covered. But anyway, without any further ado, Eben Upton. We're picking up the conversation talking about Embedded World, which is a large conference for embedded devices that we had both just attended in Nuremberg in Germany.
Embedded World, yeah, it was amazing. I mean, it was such a, I think people couldn't quite agree on whether it was whether it was a good turnout, whether it was a better than usual turnout, worse than usual turnout, but there was just an enormous amount of energy. I mean, I think people are just desperate to get back in the room with other human beings, and get back to life as it was before, you know.
Absolutely.
And of course, we had a giveaway. We gave away 25,000 Picos from the stand. We really, our message. I think a lot of silicon vendors were taking to the show the message that you can't have our silicon. We don't have any silicon, and we were taking the message we have so much silicon that we're going to give away free silicon from our stand. So we had this tiny little stand, and very often kind of thronged, people in front of it. Often people wanting to talk to us about the classic product, the Linux-based product, but a lot of people also wanting to kind of find out about us as a semiconductor vendor, which was really gratifying.
Yeah, absolutely. Yeah. Well, I mean, I think that's one of the things that is, as we talked about just previously to recording, that the RP2040 came along at a very special time. It probably always would have been the success that it is, but you were able to kind of say at a point, look, we have this, and it put it into the hands of a lot of people that maybe might have hesitated.
Yeah, that's right. I mean, it's a product we believe in. Obviously, it's we've brought a lot of our experience of what makes a good microcontroller, what makes a bad microcontroller. We've used a lot of microcontrollers over the years. We have our ideas of what makes a good microcontroller, and really that's distilled down into RP2040. So it's a product we believe in. It's got a very attractive price performance point. These things start at these things go down as low as 70 cents in middling volume, and it's got a lot of performance. So we do think it was going to be successful anyway. But I think what's happened is, engineers, we're all conservative. It's good that engineers are conservative. We stick with what we know. And I think what's interesting is the shortage of other more established microcontroller products has given design engineers a license to experiment a little, to go out and try new things. And obviously RP2040, which came into the market in January of 2021, it kind of came along at exactly the right time to tap into that newfound willingness to experiment, and to be of service. One of the wonderful things for us with RP2040 is there are businesses, particularly in that kind of maker pro kind of space, there are businesses which would have gone to the wall. You have coming to us saying, look, the alternative to buying a chip is go out of business. Kind of being of service to people, particularly smaller customers, being of service to people has been very it's been gratifying. It's been a morale booster for us.
I can imagine. And I mean, from my perspective, I mean, I studied music, and so I'm very involved in kind of the synthesizer world. And it's amazing to see the catapulting of the amount of different complex Eurorack modules that are all using RP2040 now. A lot of people do. But as we talk just now, as we just talked about, went to Embedded World, which was very nice. I was there too, and as someone who lives in Germany, it was wild to be in a big room full of people without a mask on, because that's the first time that's happened for me in 2 years. It was very strange. But we're also talking just after the Raspberry Pi Pico W and H have been released. And while, as we were saying, the RP2040 is the exciting part of that, it is rare for a company to have such a wide range of people to react to things that they release, right from the side of the industry that follows what Raspberry Pi is doing closely, to hobbyists and even younger makers who are getting into it. So from your perspective, how has the launch of the Pi Pico W gone?
I think the launch has gone extremely well. I guess a lot of organizations, ourselves included, have had to refocus their attention over the last year on sustaining existing products. So there's maybe been an adjustment in allocation of engineering resource away from making new things and towards doing the work required to keep existing things in production in this very strange supply chain environment that we're living in. So there's a hunger, particularly in the hobbyist space, the hobbyist and education space. There's a hunger for new things for anyone. Not many people are releasing anything new. Pico W has come along at a good time for that. Obviously, it adds this new layer of capability. In Pico, we produced the first board, unsurprisingly, with our own silicon on it. Since then, there's been this explosion of both end user products using RP2040, but also of other people's development, other people's take on the RP2040 development board concept. And so it's kind of nice to come back to that a year and a half in and add a really important new capability, a capability a lot of people have been asking for in the platform. We're glad we've been able to do it at only a modest cost increase. So we've gone from $4 to $6 for Pico to Pico Wireless. It's been well received. It's been great to see people getting them out of the box. When we sent sample units out to people before launch, it was good to see how quickly people were able to get online with it. And since units over the last couple of days have started arriving in the hands of actual civilians, it's been great to see that experience has been replicated in the wild.
Absolutely, yeah, and I think as you say, there's a great worth in not only getting such a small price increase onto the wireless board, but to be able to get it out there and to have good documentation straight out of the bat. From reading the documentation, I agree. One of the things about it that's quite lovely is just a few lines in the REPL, and you actually have you can search Wi-Fi in the REPL. And for people that have fought with various other boards in the past, I'm sure that's something that will mean a lot to them. And to just briefly touch on the other release, there's the Pico H, and of course there's going to be the Pico WH or HW. The idea of actually putting pins onto the Pico and being able to put it into a breadboard is one of the things that I know in the makersphere people did mention about the Pico early on. Was there always an intention to make a more kind of breadboard friendly version of it, or was that more based on feedback from the original Pico?
I think we probably would have got there in the end. I mean, if you see, we have our Zero products and the Zero products. They're the smallest big Raspberry Pi at $5 and $10, and they have headed versions. There is a Zero H, although I'm not sure I've ever seen a Zero H in the wild, but there is a Zero WH. So that naming convention follows on from the Zero products. We did a little bit more work this time. The H products are not just the non-H products, but with 0.1 inch, a couple of rows of 0.1 inch headers soldered on. We've removed the castellations, so the non-headed boards have castellations to make them easier to use as an embedded module. Taking the castellations off the side, which is nice, just makes them a little bit slimmer. And then rather than using a pair of rows of headers, we've had a custom frame designed, something that, well, I guess when you look at it on its own, it fairly closely resembles, I guess, maybe a dip socket. It's actually got two rows with crossbars with plastic plastic crossbars between them. We've had to design we've created a new standard for debug header. Previously 3.1 inch space pads for debug on Pico, Pico and Pico W. On this, we have a little JST, a 3-pin JST connector, which will be our future standard for serial wire debug on Raspberry Pi microcontroller products.
Cool, yeah, and yeah, as you say, even just breaking those things out a little bit opens it up to a much wider range of people, because there's a lot of people who are still sort of doing their first breadboarding tasks. And it's interesting to me that there are a lot of younger people who will be getting their very first experience of any kind of hands-on embedded work with the Pi Pico, and of course the newer Pi Pico HW. Moving slightly away from the Pico, but still staying within the Pi products that have sort of had their day in the last couple of years. So every major Raspberry Pi release board has always been very popular since day one, and the mainline boards, and of course the Pi Zeros, because there's nothing cooler than a very, very tiny Linux computer. I've got several Pi Zeros and I love them. The compute module, however, I might be wrong about this, but I feel like that's one of the ones that had a slightly slower uptake, as in as more recently as this compute module 3 Plus, it maybe wasn't something that was a massive seller. Then the compute module 4 came out, and it seems like the entire range is one of the most coveted things that Raspberry Pi now makes. And why do you think they took off in such a massive way?
Yeah, it's as you say, compute module products for us, they were always a slow burn. I think we're still in the volume up ramp for CM3, which is the 2017 product. So these have very long design cycles. They're very sticky once they're designed in, which is nice, because it gives us some predictability in terms of demand. But they do take a long time to design in. CM4 has been very strange though, and we asked ourselves a lot what's happened with CM4. I guess I can probably point to maybe 4 things. One, I think people do genuinely prefer the form factor. We were very big believers in the SODIMM form factor, but it's kind of perpendicular, the Hirose connector kind
Yeah.
of perpendicular form factor. It is more area efficient on the baseboard. It
Mhm.
does let you build much smaller baseboards because you don't have the metal frame of the SODIMM connector. So I
Yeah.
think that's resonated with people. I think the inbuilt wireless, the option to have inbuilt wireless has been really helpful. We had some very candid feedback actually from the Android Things team at Google back a few years ago about the challenges that not having Wi-Fi on the compute module products had. It basically said, okay, well, fine, you develop something on a Raspberry Pi 3, and okay, you can migrate to CM3, but then you've got to do a bunch of wireless conformance testing yourself. So unloading that from customers and providing antennaed and non-antennaed onboard antenna and external whip antenna options was good. Power chain's a lot easier as well. Earlier modules, we pushed the obligation to generate a bunch of rails and to sequence those rails appropriately onto the designer of the baseboard. That is not an onerous task, but it's not no effort. And so that's definitely a factor. Just putting these days, put 5 volts in, it makes all the rails. It gives you 3v3. It regulates you some 3v3 that you can use yourself. So that's been good. And I guess possibly also the supply chain thing. That it's genuinely hard the alternative, if you want to go to scale after you've developed something on Raspberry Pi, is to go buy chips in the market and to go chip on board. That path has become a lot harder.
Absolutely, yeah.
Situation, and so we probably, so all of those things together, we just blew the doors off with CM4, and of course the challenge right now is building enough of them to keep people fed.
As a very quick aside, if you're watching this video and it's the first video from Electromaker you've seen, you may not be aware of the fact that we have a weekly show on this channel called the Electromaker Show, where I talk about all things Maker and Embedded and Lovely, lots of fantastic Raspberry Pi projects along with Arduino projects, new products and things on funding websites. It's a general roundup of all things Maker and Embedded and Lovely. We also have a website which has a store, a project section for community members to share their projects, and we run regular contests, and our most recent one is quite interesting. It's with Euro circuits, and you can get a PCB of up to 500 euros made and fabricated, and you can use that PCB to enter a hardware contest with a $1,000 cash prize. If you're interested in any of these things, head to electromaker.io. But anyway, that's it for now. Let's get back to the interview.
And I mean, the chip shortage is something that is almost inevitable that it gets talked about, but I think it is something that people are a little tired of hearing about. But for perhaps a slightly different question about the chip shortage, in general, apart from the obvious lack of parts, has the chip shortage actually changed any design priorities for the Raspberry Pi team going forward, or is it more a case of kind of waiting out the storm and trying to get back to normal operation?
There's an element of waiting out the storm, certainly. And there's an element of managing our customers through the storm. We do a lot of very intensive work with our customers to understand their demand, our OEM customers, our industrial customers, to understand their demand profiles, and make sure that the vision is, while we're in a shortage situation, every object we make goes to a home immediately. We're not interested in shipping somebody 1,000 CM4s if 900 of them are going to go on a shelf for 3 months. We'd rather ship you 100 now and then ship you another 100 next month and keep it going. And that's labor intensive. I mean, we have the best part of 1,000 direct OEM relationships being maintained by the commercial team at the moment. It is a punishing experience for the people involved, and it's not something that I would want to subject people to for years on end, but it is getting people through. It is getting our OEM customers through. So there's been a sort of a change of priority probably from the commercial team, the commercial organization within Raspberry Pi, from, I guess, sales generation to demand management, to supply and demand management. Actually the same skills, right? The same people, the people who are good at one are good at the other.
Yeah.
You can repurpose people, but it is strange not to be going out and creating demand. It's strange to be just servicing demand, which is coming in. So change of focus there. On the engineering side, it's, as I say, it's really about deprioritizing new stuff. Pi Pico W and friends are so exciting, right? Because they are new stuff in a time when doing new stuff is challenging. It's about deprioritizing new stuff and focusing engineering resource on things like qualifying alternate parts. One of the ways through this crisis is, if you have a chip on the board and you can get it from 3 vendors, you make sure that you've done the work. You don't just throw the chips on and go, yeah, data sheet looks good, throw it on, ship it out the door. Actually building the prototype runs, doing the qualification, getting comfortable. Sometimes there are PCB modifications associated with it. So that's, again, labor intensive. Feels a little sad sometimes. They're victories, survival is victory. You know, keeping the product shipping is victory, but they feel like little victories where genuinely new products like Pico W feel like big victories. But it's we're doing what we have to do to get through. We're doing what we have to do to support the customers, and particularly the OEM customers, because you've got to remember these are businesses, often small businesses. If they don't get supply, they die.
Absolutely, yeah. Well, I mean, but that kind of brings me quite neatly onto another aspect of all of this, which was because going back in computing history, obviously you have the ZX Spectrum, which was such a big thing, not just because of what it was, but because of what it did to open up computing to a previously people who were priced out of it previously. And it hasn't escaped my vision that the ZX Spectrum was a computer in a keyboard that you can just plug in and get going at a fair price, and then you have Pi 400, which is a very similar thing. But I guess the main, well, actually, one interesting question is: was there any intentionality there with the the computers of the past with the computer in a keyboard, or is it just a coincidence that the Pi 400 kind of fulfills the same role for now?
It's completely intentional. The whole the thing rejoiced in a variety of names of names earlier in development, many of which were the names of popular computers. I tweeted I was an Amiga 600 owner. The Amiga 600 was not a successful product, but I had one and I loved it. Actually, it was my computer through to the end of school for the last two and a half years that I was a school student. And that was called Junebug. All Amigas had B52's song names associated, and that was Junebug. And just before we launched Pi 400, I did tweet a link to the Junebug music video. Because it is very intentional. So the whole of Raspberry Pi has, in its hobbyist element, has a very strong flavor of recapitulating aspects of the 1980s computer scene, and nothing is more 1980s than a computer built into a keyboard, right? So this is a product.
Absolutely, yeah.
Long time we did there was a Pi 300 prototype. Simon Martin, one of our engineers who developed the Pi 400, developed a Pi 300 first to sort of test out some of the concepts, particularly test out the plastics and things. So we wanted to do it for a long time. It's a fun machine. It's one that we've worked hard to keep available. You can buy one today. In a world where you have to, I mean, you can buy a Pi 4 today if you're attentive. If you keep your eyes open, but you can buy a Pi 400 very easily, and we are doing our best to keep that particular product in stock because it speaks to a particular strand of our educational mission.
Absolutely, yeah. I mean, from a personal perspective, actually, the Pi 400 is kind of impressive because I can't be sure if it's exactly the same one, but I think we may have had the same Amiga because my father was a distance learning teacher for Oxford University in programming. In fact, weirdly enough, I don't know which one it is, but I have one of the very first runs of Raspberry Pis because they gave them away as gifts to all of the Oxford distance learning teachers, weirdly enough. I guess actually a fairly important question from my perspective. Following on with that theme of getting computers into the hands of people that don't have them, it felt to me a little bit like during the pandemic, there was this blanket assumption that all school kids had a schoolroom ready computer, right?
Yes.
And I know that Pi Foundation is already doing an amazing work, but given that we've recently discovered that a lot of low-income kids simply don't, the foundation is doing wonderful work with teachers and students, but how do you see the Raspberry Pi, as in hardware or the foundation, affecting education in the UK and further afield, kind of going forward?
Yeah. I mean, wasn't that sad, right? How detached we were. Some people were. I think we were fairly attached to, actually, to the breadth, depth, awfulness of the digital divide in this country.
Yeah.
Go home and use your computer to study along. 700,000 families with no computer at all. Very well-off middle-class families without sufficient computing. A one-to-one ratio of computers to people is still pretty rare, actually, in this country. And so, you've got a parent trying to work, and you've got 2 kids trying to study, 3 kids trying to study, and there's just not enough stuff. So you're having to timeshare the machines that you have access to. So that's it was awful. And all it was doing was really just dramatizing a thing we knew existed. But it was just this flippant idea that you could send people home like that was really, really galling. So look, we did our best at the time. What we had at the time was Pi 4. I remember thinking when we were trying to help out, thinking, wow, I wish I had Pi 400. This will be over by then. I was going to launch it in November 2020. And I was like, this will be over by the time Pi 400 rocks up. And, it's like tinge of optimism there. But we had some great philanthropic support. A number of organisations, including the Bloomfield Trust in the UK, paid for us to put a program called Pi Drop, which was run by the foundation, which helped put Raspberry Pis and monitors and keyboards and mice into the hands of disadvantaged children all around the country. Quite a lot in the northeast, actually, quite a lot in the sort of Greater Manchester area. So that was good. We worked with a number of third parties. Fantastic work with an organisation called the Kansas Youth Partnership, and run by Phil Priestley, who managed. They were buying Raspberry Pis from us at cost, Raspberry Pi, 2 gig Raspberry Pis from us at cost, scrounging up the other components. What they discovered was that Phil's a former policeman, and he discovered that law firms are absolute pack rats. Their IT departments are absolute pack rat. You get a law firm, they'll have us an IT storage company somewhere with the last 3 generations of LCD monitor that they've been discarded. And they've just been, rather than being sent for recycling, they're just there. To be able to get these out, get mice and keyboards, and then build for the cost of a 2 gig Raspberry Pi, have a machine that he could donate or sell to a family in need. In the Cambridge area, we've got hundreds of units out there. So yeah, we made some. I think at the kind of hundreds to thousands to tens of thousands of unit scale, we did manage to make some difference. That's still a program that runs. Pi Drop is still a program that runs. It's interesting that it's still in an environment where possibly there's a perception the government has solved this problem by giving away laptops. It's interesting there is still demand for Pi Drop hardware. It is successful in the field. The devices do get used, and they continue to get used. Right, so it's not just they go out there, get used for a week, and then people get bored or they stop working. They are continuously in use in the field, even the unit we set out now 2 years ago. So yeah, it's been an interesting experience. More needs to be done. Pi 400 is obviously, when Pi 400 came along, that was a step change in our ability to engage with people. People are much more comfortable with the higher level of integration of Pi 400. Means there are fewer cables to connect, which means there are fewer opportunities for people to do something wrong. And that's definitely been helpful, definitely reduced the technical support burden in running programs like that. And we'll just see what we can do to keep that sort of thing going, see if we can continue to tune the platform to be better. This is what we're talking about here, is we're talking about a move from computing education, which is our historical space, right? Teaching people about computers, to computing for education, providing people with general purpose computers that they can use in education. That's quite an exciting evolution for us commercially, I suppose, but also quite an exciting evolution for the foundation's mission.
Absolutely, yeah. And I mean, and I can only hope that, as you said, this digital divide that we all became aware of is something that stays kind of in the forefront of people's thoughts. So I'm aware that we're running out of time. There is a quick question that I did want to ask you just before I let you get back to it, because from my perspective, I think I'm probably one of the many people that actually has the Raspberry Pi to thank for my entire career, because I got my start in writing tutorials for the Raspberry Pi specifically. But also, like many people, I now spend a lot more time sort of talking about Raspberry Pis and making the YouTube show and doing things like this than I do actually playing with the Pi. And also, I've got a big tabletop synthesizer I'm going to build one day. So I guess my final question would just be, what's the big kind of personal passion project for you that if you had the time, you would be tinkering away with right now?
Right. I mean, I have the same problem in that I spend, I run an organization that makes what I think is the ultimate hacker toy, right? It's the ultimate hacker tool. And I spend a lot of time doing that and very little time actually using the device itself. I mean, I use them in utility roles already. I mean, the sort of Pi-hole, Kodi. Those sorts of use cases. I use them as generic. I actually use them as probably my biggest sort of technical use of them is just as generic Linux boxes. It's often the Linux environment. One of the things I've learned over the course of Raspberry Pi is how much friendlier that environment is than any other computing environment from a getting technical stuff done perspective. And so rather than spinning up new VMs, I have a tendency to just plug new Raspberry Pis into the back of my hub at home, and I have a collection of various antique Raspberry Pis and their power supplies kind of hanging off the back of my hub. So that's probably the big thing. What would I do if I had? I honestly can't tell you. What I would do. I think I'm going to do some Pico, inspired by the real ease of use of Pico W. I was amazed when I first. It's a product that's taken a little while to get to market, and when products take a while to get to market, you kind of forget how cool they are. And then over the last month, the software has really come the software documentation has really come together. I've started playing with it a lot more, and just that immediacy of getting the REPL, of opening a REPL in the serial terminal, and then just typing a little bit of Python in, and then and you know, if you want to log temperature in your house to Logly, you know, it's 5 lines of code.
Yeah.
So I think I think a lot of those home automation applications are actually or home monitoring applications are going to turn out to be easier to do in the Pico environment than they are in the Big Pi environment. And I probably my resolution is to do more of that stuff.
Excellent. Yeah. The DIY smart home. It is a bit of a rabbit hole, I do have to warn you.
It is. I have friends whose understairs closets are testament to exactly how much of a rabbit hole that is.
Well, Eben, thank you so much for chatting to me today, and yeah, it's really nice to hear all of the story of how the RP24